AMD Strix Halo Cluster Benchmarks. Hardware enthusiasts pushing the boundaries of local AI inference have uncovered some surprising results with AMD's Strix Halo processors running in multi-node configurations. A detailed benchmark study from the local AMA community documents the first successful use of RCCL, RODM Communication Collectives Library on Strix Halo hardware, despite AMD not officially enabling it. The trick involved following a GitHub pull request that repurposes the GFX 1100 code path for the GFX 1151 architecture, requiring a local RCCL compilation and swap with VLLM's default version. The benchmark results comparing tensor parallel (TP) versus pipeline parallel (PP) approaches reveal consistent patterns across multiple test configurations. On a Qwen 3.4b model with 512 input tokens, 128 output tokens, and 128 concurrent requests, tensor parallel across two nodes achieved 454 tokens per second output throughput compared to 402 for pipeline parallel, roughly a 13% advantage. The gap widened under heavier load. At 256 concurrency, TP hit 749 tokens per second while PP managed only 285, a nearly 3x difference. For the larger Qwen 3 VL30B-A3B vision language model simulating realistic usage, TP maintained its advantage with approximately 50% better token generation speed across all tested configurations. These findings carry practical implications for anyone building local inference clusters. The author notes that all tests ran at full BF16 FP16 precision, explaining the relatively modest absolute speeds, though AWQ quantization support is progressing faster than expected. The ultimate goal, running Qwen 3 VL235B in 4-bit AWQ quantization, appears increasingly achievable. Community members testing similar configurations on dual-node DGX Spark systems emphasize that interconnect latency remains critical, with significant performance differences between NCCL over Ethernet versus InfiniBand, even on identical physical ports. LLM Inference Fundamentals Explained. For those trying to understand what makes all this inference optimization work, Hugging Face dropped a substantial explainer covering the foundational concepts. Written by Merv from the Hugging Face team, the blog post walks through attention mechanisms, KV caching, and continuous batching, the core techniques that make modern LLM inference practical rather than prohibitively slow. KV caching, for the uninitiated, stores the key and value matrices computed during attention so they don't need to be recalculated for every new token. Without it, generating a 1,000 token response would require recomputing the entire context 1,000 times. Obviously wasteful. Continuous batching takes this further by allowing the inference server to dynamically add new requests to an ongoing batch, rather than waiting for all current requests to complete. The result is dramatically better GPU utilization, especially for serving multiple users simultaneously. The community response highlighted both appreciation and appetite for more. Requests for future posts centered on state space models, the architecture behind Mamba and its variants, and deeper dives into paged attention, a technique that manages KV cache memory more efficiently by breaking it into fixed-size blocks. The Hugging Face team confirmed plans for a focused post on KV caching, particularly paged attention and hybrid models. As one commenter noted, KV caching definitely helps make local LLMs usable on less capable hardware by not recomputing the context every time. GeoVista brings web search to geolocalization. A new research paper introduces GeoVista, a 7 billion parameter open source model that achieves state-of-the-art performance on geolocalization tasks, essentially playing GeoGuessr at a superhuman level. What sets GeoVista apart from previous approaches is its integration of visual tools and web search within a reinforcement learning loop, allowing it to actively investigate its hypotheses rather than making a single guess. The training pipeline combines two stages: a cold start supervised fine-tuning phase to learn reasoning patterns and tool use priors, followed by reinforcement learning to enhance reasoning ability. The model can invoke an image zoom-in tool to magnify regions of interest and a web search tool to retrieve relevant information, mimicking how a human expert might squint at a street sign, then search for that business name to confirm a location. A hierarchical reward function leverages multi-level geographical information, improving overall performance rather than treating every guess as equally right or wrong. The researchers also curated GeoBench, a new benchmark featuring high-resolution photos, panoramas, and satellite images from around the world. They argue that existing geolocation benchmarks fail to meet the requirements for evaluating deep agentic reasoning. The images aren't detailed enough, and the localization challenges aren't hard enough. Experimental results show GeoVista surpassing other open-source agentic models greatly and achieving performance comparable to closed-source models like Gemini 2.5 Flash and GPT-5 on most metrics. Community reaction ranged from genuine interest to the inevitable question, surely there won't be GeoGuessr hacked clients soon. Agent framework chaos meets better tooling. The explosion of AI agent frameworks has created a new problem. Even after choosing one, developers still face a missing reliability layer for testing, evaluation, version prompts, and observability. A new open-source CLI toolkit called Better Agents aims to address this gap without replacing existing frameworks. It provides scaffolding and testing infrastructure that most serious agent projects eventually hack together from scratch. Running npx Better Agents init creates a production-grade directory structure including version-controlled prompts, scenario tests for conversational and end-to-end testing, evaluation notebooks, and configuration for MCP, Model Context Protocol, tool definitions. The toolkit supports whatever agent framework, coding assistant, or workflow developers prefer, whether that's Cursor, Kilo, Claude, or plain notebooks. The philosophy centers on the boring but essential stuff that prevents your agent from silently regressing the day you change a prompt or swap a model. This addresses a real pain point in agentic AI development. As systems grow more complex, the lack of reproducibility becomes dangerous. A prompt tweak that improves one capability might break three others, and without proper testing infrastructure, these regressions go unnoticed until production users complain. The project draws on similar ideas to those emerging in adjacent tools like VoltAgent, another open-source TypeScript agent framework that community members suggested could integrate with the Better Agents ecosystem. Privacy-first chat UI challenges defaults. A developer frustrated with existing chat interfaces has released AO Chat UI, actually Open Chat UI, motivated by what they describe as being horrified that Open Web UI and similar tools let administrators read all user chat data by default, with no GUI option to disable this. The project addresses several privacy and usability gaps. All chats are encrypted at rest and invisible to admins, though the developer notes server access with the .n file would still allow decryption. Password-derived encryption keys per user are planned. It supports simultaneous, anonymous, and account-based usage with different rate limits for each, configurable through an admin control panel. Branding, text, and colors are fully customizable without requiring an enterprise license, a jab at Open Web UI's licensing changes. The developer describes their motivation as wanting friends or small businesses to share VPS resources without exposing each other's data, and eventually convincing family members to switch from commercial services like ChatGPT. They acknowledge being not a developer and describe the project as vibe-coded, but it's working for their use case and released under MIT. Community discussion touched on the genuine trade-off between admin chat access controls. A GUI toggle wouldn't prevent determined admins anyway, since they could just toggle it. The developer's counterproposal, making the toggle only affect new chats while displaying privacy warnings, represents a pragmatic middle ground. Context tools for LLM-assisted coding. As LLM-assisted coding becomes standard practice, developers are building tools to help models understand codebases more effectively. A new CLI tool called Logic Stamp Context turns React and TypeScript projects into structured context.json bundles containing component contracts, dependencies, behavior hints, and documentation, all without the syntax noise of raw source code. The tool uses TypeScript AST parsing rather than LLM-generated analysis, producing deterministic output that includes inferred props, hooks, state, exports, external imports, and circular dependency detection. For Next.js projects, it identifies pages, layouts, and client versus server components. A context main JSON file ties everything together with folder indexes and token estimates, useful for understanding whether a codebase fits within a model's context window. The approach contrasts with LLM-based alternatives that achieve language agnosticism at the cost of potential hallucination and drift. As the developer explained, LLM equals reasoning layer, logic stamp equals structural layer. The project is building toward an MCP, Model Context Protocol layer, that would let models run the CLI themselves, read the bundles, and perform tasks based on the structural understanding. This represents a broader trend of creating specialized tooling that bridges the gap between raw codebases and LLM comprehension. Million-step tasks need massive decomposition. A research paper from Cognizant AI Lab in UT Austin tackles one of the most fundamental limitations of LLM-based agents, the persistent error rate that prevents scaling to long-horizon tasks. The paper, Solving a Million-Step LLM Task with Zero Errors, introduces Maker, a system that successfully completed a task requiring over 1 million LLM steps with zero errors, demonstrating what the authors call an agentic advantage, analogous to quantum advantage. The core insight is mathematical. A system with a 1% per step error rate will fail after roughly 100 steps of a million-step task. Rather than trying to make individual LLM calls more reliable, Maker uses massively decomposed agentic processes. With three key components: maximal decomposition into minimal subtasks, first to ahead by k-error correction through subtask-level voting, and red flagging to identify and reject outputs where format errors indicate potentially incorrect reasoning. The benchmark domain is the Towers of Hanoi puzzle, chosen because it has natural scaling. Optimal steps are 2 then, 1 for n disks, and a clear failure mode. State-of-the-art LLMs show high success up to 5 to 6 disks, then plummet to 0. The paper's most striking finding: state-of-the-art reasoning models are not required. Relatively small non-reasoning models suffice when properly orchestrated. This suggests an orthogonal scaling direction to making ever larger models, one focused on coordination rather than parameter count. The authors draw an analogy to chess. There was a period when human AI teams beat either alone, but that window eventually closed. Whether programming will follow the same trajectory remains an open question. Prompting strategies for Gemini models. Google's updated documentation on prompting strategies for Gemini models, including Gemini 3, provides a comprehensive guide to getting better outputs through structured approaches. The key techniques include completion strategies, few-shot prompting, constraints, and proper context provision, applicable across most modern language models despite the Gemini-specific framing. The completion strategy leverages models as advanced auto-completion tools by providing partial output and letting the model continue the pattern. For JSON generation, instead of writing elaborate instructions about field names and formatting, simply providing one completed example with the next order line prompts the model to follow the established pattern. This approach often produces more consistent results than verbose instructions that leave room for interpretation. A strong recommendation from the documentation: we recommend to always include few-shot examples in your prompts. Prompts without few-shot examples are likely to be less effective. In fact, you can remove instructions from your prompt if your examples are clear enough in showing the task at hand. The guidance also emphasizes showing patterns to follow rather than anti-patterns to avoid. Telling a model what not to do often backfires, while demonstrating what to do works more reliably. Prefixes receive particular attention. Adding JSON before expected output signals format, while input prefixes like English and French demarcate semantically meaningful sections. Search agents fail at ambiguous queries. A new benchmark called Interact Comp exposes a critical blind spot in AI agent development. While search agents have improved dramatically on complete unambiguous queries, they fail catastrophically when queries require clarification through interaction. The research evaluated 17 models and found a striking pattern. The best model achieved 71.50% accuracy with complete context, but only 13.73% when interaction was required. The longitudinal analysis is particularly damning. Over 15 months, interaction capabilities showed almost no improvement across all models, while browse comp performance improved 7-fold during the same period. This stagnation reveals what the researchers call a critical blind spot in agent development. The problem isn't capability deficits. Forcing models to interact before answering produced dramatic gains, 14% to 40%, but rather systematic overconfidence. Models confidently commit to assumed interpretations rather than asking clarifying questions. The benchmark uses a clever target distractor methodology to create genuine ambiguity. Questions use only shared attributes between a lesser-known target entity and a popular alternative, ensuring search alone cannot resolve the ambiguity. Agents must interact with simulated users to uncover distinctive attributes not given in the initial query. The example provided describes a team-based striking sport with attributes fitting multiple sports. Only through questioning can an agent determine whether the user means baseball, cricket, or the actual target. This work provides both evaluation infrastructure and natural reward signals suitable for reinforcement learning approaches to train better interaction capabilities. Audio AI gets test time scaling right. Step Audio R1 claims to be the first audio language model to successfully unlock test time compute scaling, meaning it actually improves with longer reasoning rather than degrading. Previous audio models suffered from what the researchers call inverted scaling, where performance paradoxically worsened as reasoning chains lengthened. The root cause of this failure, according to the technical report, is transcript anchoring. Conventional models, due to text-based initialization, analyze linguistic abstractions from transcripts rather than genuine acoustic properties. To resolve this modality mismatch, the researchers introduce acoustic thought refinement, an iterative training framework that shifts the model's reasoning focus from textual surrogates to acoustic analysis. The resulting model surpasses Gemini 2.5 Pro and matches Gemini 3 across comprehensive audio benchmarks. The architecture builds on Step Audio 2, combining a pre-trained audio encoder, frozen during training, operating at 25 Hz frame rate, a simple adapter that downsamples to 12.5 Hz, and Qwen 332B as the core reasoning component. The key is ensuring the model's reasoning is deeply grounded in the acoustic features of the audio itself, rather than merely about transcribed text. Inference code and model weights are available, with Docker deployment recommended for production use. The release includes a Gradio demo and detailed serving instructions using a customized VLLM backend. Synthetic Data Toolkit opens up. DataArc has released a modular synthetic data generation toolkit supporting multi-source, multi-language data synthesis with zero-code CLI and GUI options. The platform addresses a growing need. As models improve, the demand for high-quality training data increases, and synthetic data generation has become a critical capability for teams wanting to fine-tune or train models without massive human annotation budgets. The toolkit supports 3 primary data sources: local corpus-based generation, automatic Hugging Face dataset screening and retrieval, and model distillation. It works with local deployments, OpenAI APIs, and other providers, supporting English and various low-resource languages. The architecture is modular, allowing developers to customize generation and rewriting strategies by inheriting from base classes. Recent updates added async execution for faster pipelines and checkpoint recovery, letting users resume from the last successful stage rather than restarting entire runs. The project claims that a few lines of code deliver over 20% performance improvements, though as with all such claims, results will vary with specific use cases. The inclusion of a Gradio UI for non-programmers reflects the democratizing trend in AI tooling, making capabilities previously requiring significant engineering expertise accessible to broader audiences. Tiny models match giant reasoning. VibeThinker-1.5b demonstrates that exceptional reasoning performance can emerge from surprisingly small models with smart training. This 1.5 billion parameter dense model achieved reasoning performance comparable to models with over 400 times more parameters, with a total training cost of only $700 to $800. The numbers are striking. On AME24, AM25, and HMMT25 math benchmarks. VibeThinker scored 80.3, 74.4, and 50.4 respectively, surpassing the initial DeepSeek R1 scores of 79.8, 70.0, and 41.7, despite the massive parameter count difference. On code generation, it achieved 55.9 on Live Code Bench v5 and 51.1 on v6, slightly leading Magistral Medium's 50.3 on v6. The training innovation centers on what the team calls the Spectrum to Signal Principle, SSP. First, exploring solution diversity during supervised fine-tuning, then optimizing policy to reinforce correct signals during reinforcement learning. By making diversity the central technical design principle, the approach establishes that small models can achieve robust performance exceeding conventional training paradigms. The model significantly extends the Pareto frontier of reasoning accuracy versus model scale, a result with significant implications for anyone evaluating the trade-off between model size and capability for deployment constraints. Flux.2 raises image generation bar. Black Forest Labs launched Flux.2, their new image generation model family designed for production creative workflows rather than demos. The release includes multiple variants spanning fully managed APIs to open-weight checkpoints, with capabilities including up to 4 megapixel generation and editing, multi-reference support combining up to 10 images, and significantly improved typography. The model family comprises Flux.2 Pro, state-of-the-art API service, Flux.2 Flex, developer control over parameters, Flux.2 Dev, 32B open-weight model on Hugging Face, and Flux.2 Klein, Apache 2.0 licensed size distilled from the base. The open-weight dev model combines text-to-image synthesis and image editing with multiple input images in a single checkpoint, claimed as the most powerful open-weight image generation and editing model available today. Technical improvements include a retrained latent space for better learnability and image quality, addressing what the team calls the learnability, quality, compression trilemma. The model couples a Mistral 324B parameter vision language model with a rectified flow transformer, bringing real-world knowledge and contextual understanding, while the transformer captures spatial relationships and material properties. Black Forest Labs frames their approach as open core, combining open models for community experimentation with production-ready endpoints for teams needing scale and reliability. SAM 3D Body recovers full human meshes. Meta's Superintelligence Labs released SAM 3D Body, a promptable model for single-image full-body 3D human mesh recovery that demonstrates state-of-the-art performance with strong generalization across diverse conditions. The model estimates human pose for body, feet, and hands based on the Momentum Human Rig (MHR), a new parametric mesh representation that decouples skeletal structure from surface shape. The model supports auxiliary prompts including 2D key points and masks, enabling user-guided inference similar to the SAM family of image segmentation models. This promptability is particularly valuable for handling occlusions and unusual poses where fully automatic approaches struggle. Training used a multi-stage annotation pipeline, combining differentiable optimization, multi-view geometry, dense key point detection, and a data engine to collect annotations covering both common and rare poses across a wide range of viewpoints. The encoder-decoder architecture outputs 3D mesh vertices and camera coordinates, 3D and 2D pose key points, camera translation parameters, estimated focal length, and separate parameters for body pose, hand pose, and body shape. Code, model weights, and a dataset are all available, with an interactive demo accessible through Meta's AI Demos portal. The decoupling of skeletal structure from surface shape in MHR allows improved accuracy and interpretability compared to approaches that entangle these representations. Security Roundup, Cloudflare and beyond. This week's security news includes a significant Cloudflare outage that, for once, wasn't DNS. The incident stemmed from a database management change combined with a safety limit that failed unsafe when exceeded. A query that previously returned data only from the default database was updated to return all databases a user had access to, causing a feature list for bot classification to exceed its 200-item limit. The real trouble came from different behaviors in Cloudflare's two core proxy versions. The older version classified all traffic as a bot when it failed. The newer Rust code threw an error, leading to 5xx HTTP errors and widespread internet disruption. The root cause was an .unwrap call that wasn't caught in review. A function could have gracefully failed, but instead crashed the entire application. Other notable security items include bad audio, malware from AP24 using control flow flattening to resist analysis, and several, not technically vulnerabilities, in MPDF and ESBuild that highlight the tension between library capabilities and input sanitization responsibilities. The MPDF issues involve URL handling that could leak information or run code, but the library explicitly assumes sanitized input. Similarly, an ESBuild XSS potential requires the ability to upload arbitrary folders to the server. If you can do that, you already have plenty of other attack vectors. Electromagnetic warfare emerges as NATO gap. A RAND Europe analysis argues that electromagnetic warfare represents a critical blind spot for NATO, with implications for any future conflict with Russia. The war in Ukraine has demonstrated that control over the electromagnetic spectrum, where communications are jammed, drones blinded, and precision weapons thrown off course, can decide battle outcomes. Russia maintains over 400 radar sites and at least comparable EW assets, with capabilities deeply embedded in military formations and doctrine. Their preferred strategy uses electronic reconnaissance to find and isolate Ukrainian positions before overwhelming them with artillery. Meanwhile, NATO's practical EW experience is limited to exercises and simulation constrained by peacetime policy requirements. The alliance's dependence on U.S. capabilities, including E-Link collection, threat library management, and jamming, has become a vulnerability as U.S. attention shifts elsewhere. The analysis recommends European NATO members invest in EW expertise, material, and infrastructure independent of U.S. participation, mandating systematic integration of electromagnetic warfare into exercises and wargames. A new EW coalition with Ukraine aims to bridge the knowledge deficit, but deep capability takes time to develop, especially when specialist skills and experience are scarce. The piece echoes broader concerns about European defense readiness in an era of shifting U.S. priorities. 44 years of Unix in one repository. A fascinating software archaeology project documented the creation of a Git repository tracing Unix evolution from its 1972 inception as a 5,000-line kernel to 2015 as a 26 million-line system. The 1 gigabyte repository contains 659,000 commits, 2,306 merges, and approximately 850 contributors spanning Bell Labs, Berkeley's CSRG, and the FreeBSD project. The construction methodology required extraordinary detective work for authorship attribution. Methods included reading biographies, research papers, and internal memos, examining source code directory names. Early editions split kernel code into directories by contributor, like Ken and DMR for Ken Thompson and Dennis Ritchie, email correspondence with people present during development, and even posting queries on Unix Stack Exchange. The first and second research edition manual pages contained an owner section listing responsible individuals, a practice that disappeared in the fourth edition before resurfacing as author in BSD releases. The repository enables Git blame to trace code provenance across decades. Analysis of FreeBSD 9 reveals surviving code chunks from BSD 4.3 and earlier, with the oldest surviving code being an 18-line sequence in timezone.c dated January 10, 1979, 36 years before the paper's publication. Interestingly, code from the 386 BSD and FreeBSD 1.0 effort to create an open-source operating system from Berkeley-released code does not appear to have survived in FreeBSD 9, suggesting significant rewrites despite the project's historical importance. Backend in a single binary. For developers wanting a quick backend without infrastructure complexity, PocketBase offers a compelling proposition: an open-source real-time backend distributed as a single executable file. The SQLite-based system provides authentication, database management, and a REST API out of the box, integrating with front-end frameworks through straightforward client libraries. The simplicity is evident in the API. Listing records, creating new entries, and subscribing to real-time changes all work through intuitive method calls. The JavaScript example shows pb.collectionExample get list for listing, pb.collectionExample.create for creation, and pb.collectionExample subscribe for real-time updates. This approach dramatically reduces the barrier to entry for prototyping and small applications where setting up a full database server, authentication system, and API layer would be overkill. The project represents a broader trend toward developer experience optimization, making common tasks trivially easy while maintaining the flexibility to scale when needed. For AI application developers specifically, having a quick backend for storing conversations, managing user state, or tracking agent interactions can accelerate prototyping without committing to heavyweight infrastructure decisions before requirements are clear. Claude Code goes free via OpenRouter. A developer at MadAppGang released Claudish, a translation layer that lets Claude Code, widely considered the best agentic coding tool, work with any model via OpenRouter, including free tier options like Gemini 2.0 Flash, DeepSeek R1, and Grok. The pitch is straightforward. npm install Claudish, and Claudish Free provides access to Claude Code's sophisticated agent capabilities without the $20 a month minimum or accumulating API costs. Importantly, Claudish doesn't fork Claude Code, it translates at runtime. When Anthropic ships updates, new tools, or better agents, they work automatically. The system supports over 580 models, full tool calling, MCP, Model Context Protocol servers, thinking modes, and all Claude Code commands routed through whichever model the user selects. The developer reports using Gemini 3 Pro for complex planning and Grok for fast context work. The release drew interest from users wanting to point Claude Code at local inference via LM Studio, suggesting potential for 100% local AI coding assistance. This type of translation layer represents a broader pattern of decoupling agent frameworks from specific model providers, allowing users to optimize for cost, capability, or privacy constraints while maintaining consistent tooling. The MIT license ensures the approach can be freely adapted. AI-assisted coding workflow wisdom. A detailed Chinese language post on AI-assisted coding workflows, which commenters noted appeared AI-generated itself, creating an appropriate meta-commentary, articulates a middle ground approach between pure manual coding and unconstrained vibe coding. The author argues that after 3 months building real features across front-end, back-end, and AI pipelines, the extremes don't work. Manual coding is too slow, while pure AI coding breaks down as codebases grow. Practical recommendations include learning new tools and architectures manually before switching to AI assistance, performing more manual coding with newer frameworks until design understanding is solid, using spec-driven development when collaborating with agents, having AI generate tests but still performing manual verification, using one agent at a time with close monitoring, treating AI like a junior developer who needs clear direction on small, well-defined tasks, and simplifying AI-generated code, especially when others will work on it. The post's observation about vibe coding leading to 100 times faster arrival at common software development cycle problems rings true. The 2,000-line single-file monolith that no model can reason about is a recognizable failure mode. The recommended hybrid approach mirrors emerging best practices. Humans define architecture and verify results, while AI handles implementation of well-scoped components. One particularly useful insight: if planning with AI, ensure specifications stay synchronized with code, or they become useless, a challenge that current tooling doesn't fully address. Agentic memory and vector infrastructure. An emerging perspective on AI infrastructure argues that the future isn't monolithic models, but rather high-speed, hyper-connected data systems where intelligence emerges from coordination rather than consolidation. Projects like AgentDB treat memory as a cognitive substrate where every agent interaction is stored as structured data queryable by other agents, externalizing reasoning rather than locking it in black boxes. The RuVector project reimagines vector databases using hypergraphs, where single connections can link multiple items simultaneously rather than just pairs. This captures complex relationships that simple similarity search misses. For speed, the implementation uses HNSW, hierarchical navigable small world graphs, essentially an express lane system where search time grows logarithmically with database size rather than linearly. A key insight: HNSW isn't just for retrieval, but can be embedded directly into neural architectures as a differentiable memory layer. Instead of attention mechanisms scanning every token, networks can query HNSW to pull relevant memories on demand, sparse retrieval replacing dense computation. The hard engineering problem is making index updates fast enough for real-time learning. Traditional HNSW assumes static data, while agentic systems require continuous writes from potentially billions of concurrent agents. This infrastructure gap, if solved, could fundamentally change the economics of AI systems.